Hello students, welcome back. In this video, I'm going to teach you how to solve one more complex question wherein you have to prepare the orthobromobenzoic acid using one of the given methods. The first reaction given here is of benzene. It is undergoing electrophilic substitution reaction, nothing but here Friedel-Crafts alkylation. So you are going to get toluene as a product. This upon oxidation. So the moment you see KMnO4, you should know that it is a strong oxidizing agent. Therefore, you are going to get the benzoic acid. So we got this part now. So the last reaction here is bromination. So where the bromine should go. So that depends on the group present on the benzene. So COOH is a minus R electron withdrawing group. Hence, it is a meta-directing group. So it will orient the bromine towards meta position. Hence, you are going to get meta-bromobenzoic acid, not the ortho. So we are getting isomer means this is not the correct method. Let's take the second set of reactions. So the first reaction is same, that is Friedel-Crafts alkylation. So after that bromination is done. So where the bromine will go? Methyl is electron donating through hyperconjugation and inductive effect. Therefore, you are going to get orthobromotoluene and parabromotoluene like this, right? So this upon oxidation, what you are going to get? Orthobromobenzoic acid para. So you are going to get both the products. So here we are getting mixtures, right? And para will be major because we know that there will be steric hindrance at the ortho position. Hence, the bromine prefers to go to para position. Therefore, this is also not recommended. Although we get this as a product, this is not recommended. That's what I mean. So let's check the third set of reaction. So there is a para-nitrotoluene. So this upon bromination. So you can directly write that product here. Where this bromine will go? Will it go to ortho, meta, or para? See, para is already blocked, right? So this is a electron donating and it is ortho-para directing. Since para is blocked, it is going to the ortho position. So it is forced to go to ortho position, although there is a steric hindrance. So what happens now? We are getting orthobromonitro-toluene. So this upon H2 palladium carbon means what? It is a reduction. So which group will undergo reduction here? Nitro is susceptible to undergo reduction. So what we are getting here? We are going to get an amine. And here it's aniline, right? So NH2 group. So then what is done here? HNO2, H3PO2. That is nothing but diazotization followed by H3PO2 means this will undergo diazotization and then you are going to get CH3PR. See, we are so close to the product now, right? So all you have to do is oxidation. Then you are going to get the orthobromobenzoic acid. Students, remember this is called as protection and deprotection. First, when toluene is taken and nitration is done. So this is one of the major products, right? So you have protected the para position. Then what did you do? You carried out your favored reaction, nothing but bromination. And in the end, from diazotization, then you have removed that NO2 group, right? So that is nothing but deprotection. So that's why we are getting this as a major product. Therefore, the correct option is option C. However, we can just quickly write for the option D as well. So this is a Grignard reagent with carbon dioxide means the phenyl will attack the carbon dioxide and you are going to get benzoic acid. First you get the salt, hydrolysis will give the benzoic acid. So this upon bromination, you are going to get meta-bromobenzoic acid. Similar to the first set of reaction. Therefore, this is also not recommended. So students, what you understand from this is whenever there is an electron withdrawing group and if there is nitration, bromination or Friedel-Crafts alkylation is done on that benzene ring, then it prefers to go to meta position. But if you have to get it on ortho or para, then you have to carry out series of reactions so that you will get those products. I hope I made this clear. If you still have any question, you can ask them in the comment section. Thank you.